right, so our last lesson in chapter 3 before we move on to chapter 4, and we're going to be talking about linear versus nonlinear functions. So back to that thought of functions. But when we talk about linear versus nonlinear, we had to know slope before we could really understand the difference between the two. So let's go back to the words. Linear, nonlinear. Linear has the word line in it. These are going to be our lines, our constant rates of change. Non means not linear. So moving right along, consider the following set of ordered pairs. So we have this set of ordered pairs. We're going to go by 2s across the bottom. 8, 10, 12. And then we'll just go by 1s going up. So 2, 1. So there's our first point. 5, which is halfway in between, 3. And then 8, 5. And then 11. So if that's 5, 6, 7. All right, so here are our lines. If I were to connect them, our lines, our dots, if I were to connect them, they would create a straight line. And so this is what we consider linear. It has a constant rate of change. So if I were to take any two of these points, I'm going to end up with the same slope no matter what. And the graph is a line. That's about all there is to say about it. The reason I'm not drawing a solid line here is because we're just saying that they're ordered pairs. We're not saying that there's a connection between them. So that's why I just kind of drew a dotted line to show you that they were in line. All right, I don't know why on mine it's now putting up that blank space, but here we go. We have the height of a juggling ball. If you notice, this is not a straight line. It's a curve, so this is what we call nonlinear. Again, non being not. So not a line. And this is not a constant rate of change. No constant rate of change. And so that's those. And when we're looking at a graph, it's as simple as line versus curve, or just anything that's not a line. And then when we're looking at situations, if we can tell the slope is a constant rate of change. So if we don't have a constant rate of change, then we don't have a linear function. It would be a nonlinear function. So example 1, identify whether each graph is linear or a nonlinear function. So here's our first graph. You're looking at it, it's a line. That is linear. Here it's what we call a parabola, but it makes that U shape. It is definitely a curve, so this is nonlinear. And our third one, yes, these are straight, but because we're not continuing on past this point and we go the other direction, this is nonlinear. And so that's us looking at a graph to answer those questions. Looking at tables. When we're looking at tables, we're just seeing, do we have a constant rate of change? So I look at my x values. 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. 5 minus 4 is 1. So my inputs have a constant rate of change. 8 minus 5 is 3. 11 minus 8 is 3. 14 minus 11 is 3. 17 minus 14 is 3. Now here's the kicker. Yes, you want to check the whole table because it just takes one thing at the bottom that's not the same, makes it a nonlinear function. That's how this works. So, but here we have all 3s, all 1s. 3y divided by x, 3 divided by 1 is a rate of change of 3. So this is a linear function. Whereas when we look at this other, let's look at this one, we've 1 minus 0 is 1. So here we are changing, we're increasing our x values by 1 each time. 5 minus 3 is 2, 6 minus 5 is 1, 5 minus 6 is negative 1, and 3 minus 5 is negative 2. And so this one is nonlinear because this is not constant. Now, don't just go, you just got to be careful. If this was not constant over here, but also we weren't showing a constant on the x values, excuse me, what I would want to do is make sure that I do the y divided by x and make sure it doesn't divide to the same number. But here, all of our x values were the same, so y divided by x was not going to save our rate of change here. And so this is a nonlinear function. In example 2 here, again, we're looking at tables. So we'll look at this first table. I'm increasing by 1s on this side, so all of these are increasing by 1. Negative 8 to negative 16 is subtracting 8, and then we subtract 8 again, and we subtract 8 again, and we subtract 8 again. Or you're doing negative 40 minus the negative 32, negative 32 minus the negative 24, etc. But I look at it and I notice that we are subtracting 8 each time. And so this has a rate of change of negative 8, so it is linear. And so if I were to write that explanation, I would write it has a constant rate of change. All right, next one. Again, our inputs are changing by 1 each time. Our output, 2.5 minus 1.5 is 1. 5.5 minus 2.5 is 3. 8.5 minus 5.5 is 3. And 10.5 minus 8.5 is 2. So now constant rate of change. So therefore it is non-linear. All right, so we're changing by 1 each time for our x values. 1 to 3 is 2, 3 to 6 is 3, 6 to 10 is 4, and 10 to 5 or 15 is 5. And so it is increasing by 1 each time, but it's not the same number the whole time. And so this again is not a constant rate of change, so it is non-linear. And that's how that works. We have a couple longer examples coming up, and so those are going to go into the next video. It gives us some more real-world application of linear and non-linear examples. So see you there, 8th graders.